We begin the process of cellular respiration with glucose, which we find in carbohydrates. Then, in the cytoplasm, the glucose will undergo glycolysis. The glucose molecule is broken into pyruvic acid, which is packaged and carried up by the acetyl-CoA. Acetyl-CoA will bring the pyruvic acid into the mitochondria, where the package will go through the Krebs cycle. As a result of the glycolysis, 2 ATP is produced.
In the Krebs cycle, the acetyl envelope is further broken down into a surplus of hydrogen ions and CO2. CO2 goes into the atmosphere, and the hydrogen and the electrons move through the ETC. The NAD+ helps the hydrogens move through the ETC. The hydrogens break off, bonding with the highly electronegative oxygen molecules that we breathe in to form hydrogen. As the hydrogens and the electrons move through the ETC, some of the hydrogens go into the mitochondrial matrix, creating a hydrogen ion gradient that provides the energy for the ATP synthase to form ATP as they move from a high to low concentration. As a small recap, I'd like to cover some of the minor details that we may have not highlighted directly in our video. Glycolysis, which is one of the major metabolic pathways, turns glucose, which is C6H12O6, into pyruvic acid, which is C3H4O3, both of which are CHO molecules. While we didn't say this directly in the video, the pyruvic binds to the coenzyme, acetyl-CoA, so it's not just packaged up and shipped. Lastly, the oxygen that we breathe in is so important to us because of its electronegative properties. It loves to accept electrons because it has 6 valence electrons already, and it has a smaller atomic radius than the other molecules with the same amount of valence electrons. This is explained by the periodic table trends. As we move right on the periodic table, the atomic radius decreases, and as we move up, the electron negativity values also increase.